230 volts. Okay, let's take a look at it from the inside. So this is it. I think I already gave you a teaser. Let me remove the wire so that we start from zero. Alright, so I quickly removed all the wires so that everything starts from zero. Looks like I forgot to remove them when I was doing my little project. So we can see here that we have 1, R1, R3, 3, 2, 1, 2, 3, 4. I named the poles like this over here just to simplify it, but this is the way that they are named. 1, 2, these two are connected to each other. R1, R2 connected to each other. R3, R4, 3 and 4, which are the normal ones. In my case, if I take my multimeter in continuity mode, these are normally open and these are normally closed. So this contactor has the same configuration that I just drew over here. Just some external features about it. It is DIN rail compatible. Over here I can hook it up to the rail so that it stands on the wall. Let us talk about it inside before we talk about the external so that we can appreciate what it has to offer. Hold on a second. Let me get something. I want to take a quick step back. So this was an old step up, step down transformer that I disassembled. I left the primary coil and removed the secondary coil. If I wire it, it will make a lot of sound, but it's worth the demonstration. Let me plug it in. Okay, so I got the wires ready. This is going to be my positive. I'm gonna get some insulation tape so I don't zap myself, because these two are going to be in pretty close proximity. Okay, so what happens when I turn this on, when I give it power? The current will go through the coil and it will create a magnetic field and it will become magnetic over here. And we can see that if I take some piece of metal. Where's the metal when you, okay, we can use this skim. It's gonna make a lot of racket because these are loose, so it's gonna be vibrating very quickly. So the pieces of metal over here are going to create like a zzz sound. It's going to travel through the air. So let's see what we get. Okay, see? Now what happens is if I take this crocodile clip and I turn it over, it's going to get magnetized. Now if I remove the current, that's what's going to happen. So suppose that this coil over here is connected to the priority that I want. It's delivered, there is power being delivered to the house according to our example via the grid, and then the generator turns on. It's going to activate. It's going to change over in a split second. And then the generator turns off, it will go back to the grid. And it will let go of the mechanism. We will talk about the mechanism in a bit. So let's start to put everything together. This part over here is the same part that's over here. Where's the coil? This is the coil. We have a coil over here. So if I take this and I put it in here. Remember all that shivering that was going on over here? How it was going zzz. That's why they have these rubber stoppers, so that it can cushion it. So if I take this and I put this over here, I now have a similar structure to what's going on here. Okay, so that's going to create a magnetic field. It's going to stick to the inside over there. So what should happen now? There is a mechanism in here. If we pay attention, I don't know if I can remove this. I doubt I can remove it. Wait. I don't think I can remove it without damaging it, so I'm not going to do that. You can see on the inside how everything is mechanically connected. The top one, that top piece of copper, goes to this. This one to this. These two are hidden on the inside because they are connected to the armature that will excite it. And you can see on the inside over there how this is going to be moving. So what we are seeing inside is basically a piece of metal over here, a piece of metal over here. These are the outer contacts. And then we're going to have two pieces of metal over here, which are going to be connected to the armature. That's like that. And the coil will either suck this in or bounce it out using this spring. They are going to come together or they will release from each other. So this is the back part of the housing, and this is the part that comes over here to complete the magnet. It's like having this right over it. So if I take this one, I'm going to put it right in here. Let me get some light because the sun is going down. I should also talk about how I made this light a spotlight. I'm going to take the coil, put it in there. You will notice the coil has the positive and the negative, and these two are shorted together to have a common negative. So this will go over here. Excellent. And how will we excite this? How is this going to give the signal to release or to come? We have this spring which sits right on top here. And then I have this one which is going to come on top. See, I have A1 and A2. A1 and A2, those are the connections for the coil. And A2 at the bottom is common with the A2 on the top for the common ground, for the common negative. And this will sit right in between like that. Okay, so I give the coil some energy, it will suck in like that. I release the energy from the coil, it will go back out. Let's put this all back together. All right. You can hear a lot of fiddling inside it. That's because it's not a very expensive contactor. It's a cheaper one. So this is great. Let us see the behavior of the coil. Now, it is worth mentioning that it does have a kick to it because we're exciting it with some pretty high voltage. Not high voltage, the outlet current, the outlet voltage, 220 volts. I'm going to remove this cover so that I can immediately clip onto the terminals over here. And I'm going to take this and I'm going to put it right here. So now we're going to see this in action. I'm going to disconnect that so that I can do it with my hand. So that's in. Now, when I take this and I touch it with this screw, it's going to pull it. It's going to excite the coil. So let's see. So now, in our case, these two are going to be open and these two are going to be closed. When I release it, it's going to reverse that. These two are going to be back open, closed. 1, 2, 1, 2. That's the release of the magnet that we saw. And the integrated system of this magnet. Now that's done, we can move on. So we saw how the magnet excites, we saw the structure on the inside. Now we can actually wire it up. We can connect it to a load, a motor, a lamp, and see how this is in action.